We will use our knowledge of trig graphs from the previous video to help us solve trig equations. Trig functions are periodic, so trig equations will have many solutions. For example, there are an infinite number of solutions to the equation sine theta equals a half, as can be seen by this graph, where we see the line y equals a half and the graph of y equals sine theta. Here are 4 solutions circled there. Because there are an infinite number of solutions to trig equations, we often work within a restricted domain, which usually involves one period. So for our sine graph, we'll work between 0 and 2 pi. To find the solution to sine theta equals a half, we can read the solutions off from a graph. So reading off our first solution there, we see that that's about a third of the way up to pi on 2. So a third of pi on 2 is pi on 6. From our solution of pi on 6, we can obtain a second solution using our graph. We need to come back pi on 6 from pi. So our second solution will be pi minus pi on 6, which will give us 5 pi on 6. We can use the unit circle instead of the graph to find the second solution to sine theta equals a half. Sine is the y value, so we'll find where y is a half. The first angle there is pi on 6, which we can obtain using our exact value of sine of pi on 6 equals a half. Our second angle is just pi on 6 back from pi. So our second angle is pi minus pi on 6, that is 5 pi on 6. In this example, we're going to solve this rather difficult equation involving cosine squared and sine theta. So in order to do so, we'll need to write it all in terms of either sine or cosine. We'll convert the cosine squared theta into sine squared theta using this identity. So we can write cosine squared theta is 1 minus sine squared. We'll replace the cosine squared theta there in the equation with 1 minus sine squared theta. We can expand our brackets there, and then we'll put everything over to the right hand side there so that we'll get rid of some of those negative signs. Now we have an equation simply in sine, and in fact this is a quadratic equation. If we replace the sine theta with an x, we'll have 2x squared plus x minus 1 equals 0, a quadratic equation. We can solve that by using the quadratic formula, or we can factorize as I've done here. So we really have the equation now of sine theta plus 1 times 2 sine theta minus 1 equals 0. We've got factors that multiply to 0, so one or the other factor has to be 0. Sine theta equals negative 1 will make the first factor 0. Sine theta equal a half will make the second factor 0. Now we've already solved that equation sine theta equals a half in a previous example. We had pi on 6 and 5 pi on 6 as our two solutions. Our solution to sine theta equals negative 1 is down here. There's our negative 1, our y equals negative 1. And our angle is the angle that takes us all the way around to there, which is 3 pi on 2. So we now have these 3 solutions, and we'll just put those in ascending order there to give us our 3 solutions. We prefer to write our answers to trig equations in radians, although angles in degrees are also acceptable. Now, sometimes it's easier to work in degrees and then convert the answers to radians. So, for example, if we were looking for the inverse sine of a half, in radians we'll get this decimal approximation. We won't get pi on 6 exactly, although in degrees we will get 30 degrees. So sometimes it is easier to work in degrees and then just convert. To get our 5 pi on 6, of course, we would just multiply that answer by 5. Let's look at a worded example. We have the vertical displacement y of an object at the end of a spring, which itself is being moved up and down, is given by that equation. where t is time measured in seconds. Find the first two values of t for which the displacement is 0. So we have the equation there that we need to solve. So we can take sine t out as a common factor firstly. We have two terms being multiplied to give 0, so one or the other term has to be 0. Now if the second term is 0, then cosine t has to equal negative 3.5 divided by 2.4, which gives us negative 1.46. Now sine t is 0 when t is 0 or pi, that's the first two values there. And the second part of it gives us no solution because cosine is always between minus 1 and 1, and of course negative 1.46 is outside of that range. So the only two solutions are t equals 0 or pi. The graph of the function is shown there, which you can get on a graphing device. And we can see that the two solutions there are the two x-intercepts. We've seen the trig functions are periodic, so the trig equations will have many solutions, not just one. And to find the solutions, we can use the graphs of the trig functions or the unit circle to help us locate all the solutions.